In this problem, you're asked to write out the equation for this set of graphs. All right. These graphs are absolute value graphs. So the general form that we're looking for looks like this. F of x equals a times x minus h plus k. So remember, a is describing any stretches, compressions, or reflections. With absolute values, I think of it as the slope of the right-hand side. Your h is a horizontal translation, so how much to the left or to the right it's been shifted. All right. X minus h, my gosh, slides the graph to the right, and x plus h translates the graph to the left. This k value, if it says minus k, goes down, and plus k moves the graph up. So that is a little guidance thing that I use just to write the equation. Alright, so here we go. I'm going to zoom real close in on this red one. So the first thing I do is I usually find my vertex, and I use that to help me to describe the translations. Usually remember that vertex is on the origin unless there's been a translation that's happened. So to go from the origin to this point, it has moved to the right by 2, and I see a translation up by 4. Then we need to identify our a value, which again is the slope of the right-hand side of the graph. So my next anchor point on this side is right here. So for my a, I'm looking at rise of 1 and a run of 1, which is an a value of 1. Now, if your a value is 1, we usually do not write it when we go into the writing the equation part, because it's implied. And so when you write the a equals 1 on there, it makes your equation a little harder to read. So we're not going to write this a on here, but we will for the other problems. Alright, so I have f of x equals 1 times the absolute value of x, and we're looking for our h's, right? So to show to the right by 2, I say minus 2. Remember, that feels backwards because the general form has x minus h. So if I were to put in a positive 2, it would say x minus 2. So it feels backwards here, but that's the reason why. It's the minus that's in the general form here. Then to show up 4, I say plus 4 outside. Alright, let's try the next one. So on this next one, I see my vertex right here. The only slide that's occurred, or translation that's occurred, is being moved to the left by 1. There's no k value, because it hasn't been moved up or down. Then I need to go ahead and find the slope of the right-hand side, which is my a value. So my next anchor point, which is going through the little crosshairs here, is right here. So if I count, I'm rising by 3 and running by 1, which gives me an a value of 3. So now we just pop it into our general form. So I say f of x equals my a, which is 3. And then to show left 1, that's going to be an h value. So I'm going to say x plus 1. And again, because there's no k, don't add anything there. It's good. Alright, one more time. Now notice this V shape is upside down. That comes from a vertical reflection. So when I go to find my a, and I'm doing this, you could see this section has a negative slope. But you could see there, that's why I specify it has to be the right-hand side to get your a value. Because otherwise you would not have the negative value here. Okay? So if I think about rise and run, it falls by 1, and it runs by 2. And then looking at my translations, I see that the vertex goes 2 to the left from the origin, and I see that it goes down 1 from the origin. So now I have my 3 values, and I'm set to go for my equation. So I say f of x equals my a, which is negative 1/2, times the absolute value. To show left 2, I'm going to say x plus 2. And then to show my down 1, I put a minus 1. here at the end. So there it is, writing equations for an absolute value.